Okay, so we just have a little bit more to finish up here on Chapter 6, Introduction to the Skeletal System and Osseous Tissue. So the hormone effect on bones, we mentioned from the pituitary growth hormone, from the thyroid, thyroxine, and calcitonin, from the parathyroid, parathyroid hormone, and ovaries and testes, we get testosterone and estrogen. So the thyroxine and growth hormone are really working together, and they're promoting bone growth. Right, and this is again part of your overall growth. And they do this through activation of osteoblasts, both of them. Parathyroid hormone and calcitonin work together to maintain calcium homeostasis and balance. So parathyroid hormone stimulates osteoclasts while calcitonin inhibits them. All right, and in this way, parathyroid hormone is going to reabsorb bone in the event that your blood calcium's low, and calcitonin is going to cause your bones to not reabsorb and basically deposit calcium if it's high. And we'll look at this in the next slide as well. Sex hormones, basically like growth hormones, promote the osteoblasts, but they also stimulate this rapid ossification, whereas growth hormone will continue. It doesn't change the epiphyseal plate to a line. Sex hormones, which increase rapidly and significantly, I should say, at puberty, basically result in the cessation of elongation of the bones. Right? Now, estrogen and testosterone continue to help us with depositing and making new bone, but it's that apositional growth, that widening. So here's a figure that, again, really enlightens us about this calcium homeostasis. So it turns out, again, calcium isn't just for the bones. It does a lot for us. We need it for bone, but it also helps us with neuromuscular function. It regulates heart rate, how strong, the strength of contraction of cardiac muscle, your clotting of blood, contraction of smooth and skeletal muscle as well as cardiac, and then regulation of neural conduction that we'll see later on when we talk about the nervous system. So a very, very important ion, and again, it's a mineral in the form that we're talking about here, but it's ionized in the body, right? So this level in the blood, homeostatic balance, is around 10 milligrams per deciliter, 100 milliliters of blood. And so if it goes up, we are out of balance. If it goes down, we're out of balance. And we have to have a solution for both of those situations. So when blood calcium levels drop, right, below 10 milligrams, this causes the activation of cells in the parathyroid gland, which start to produce and release parathyroid hormone. Okay? This then is a messenger that basically, released into the blood, will circulate and target or tell, right, as he said, a messenger, the osteoclasts in the bone. It'll get them active and start them to reabsorb bone, right? That's their job. They're bone destroyers, basically, through the acid that they produce and release. And so they'll start dissolving bone and releasing calcium into the blood, right, to solve the problem. It'll also target, parathyroid hormone will target the kidneys and have them retain calcium. Calcium can be lost in the urine, or it can be returned to the blood. And so in the presence of parathyroid hormone, the kidneys retain or return more calcium to the blood, right? And we call that reabsorption. And then we also get, this also starts with the kidneys. The kidneys are also targeted by parathyroid hormone to convert a pre-vitamin D compound that we make, and the liver makes and releases. So this pre-vitamin D compound is circulating in the blood and goes through the kidneys. And in the presence of parathyroid hormone, we increase the activation of this chemical. And when we have active vitamin D, right, which the kidneys will activate it, that vitamin D then targets the small intestines to allow us to absorb more calcium from our diets. So if these things are working together, we would increase the calcium levels in our blood. Okay? Now what goes down comes up. So if you had more calcium in your blood than you should, more than 10 milligrams per deciliter, then you wouldn't be making parathyroid hormone, right? You'd be making thyroids. The thyroid gland would be making calcitonin. So calcitonin should have an opposite effect, and it does, right? Osteoclast activity is stopped or inhibited, so no more bone absorption, no more calcium release into the blood, because remember the problem is you have too much already, right? And we would also, right, decrease this reabsorption by the kidneys, so reversing both of these, right, situations. And in doing that, we would see this decrease in calcium. We also increase osteoblast activity when the calcitonin's around, which means that we remove this excess calcium from the blood and deposit it in the bone. Problem solved, right? Right? And then bone function also is, right, the formation of blood cells, and we call that process hematopoiesis, right, production of blood cells. And this occurs in your red bone marrow. I said again, there's two types of marrow that we find in any spaces in the bones. If it's the medullary cavity, this continuous solid in long bones, it's generally yellow marrow, which is fat and can store energy. If it's in the spongy bone, it's generally red bone marrow, and it gets its appearance because of this molecule hemoglobin. And hemoglobin is necessary to make red blood cells. And so this red bone marrow is the exclusive site for the formation of blood cells. And this is all blood cells. Your red blood cells, your white blood cells, your platelets are made. And there's this, right, stem cell called a hematocytoblast or hemocytoblast. And it is going to, right, produce all those cells. And we find this red bone marrow again in spongy bone, and in the axial skeleton, and in the epiphyses of some of our long bones. Right? When we do bone marrow transplants, we're after the red bone marrow. Right? We're not really caring about the fat. I said if you want to see that fat, go and purchase some red meat with the bone still in it, and you'll easily see this because a lot of cuts come from those large thighs of cows. All right, so that pretty much completes what we want to go into for the foundation of the skeleton. In the next two chapters, one's devoted, chapter 8, to appendicular, and the other is devoted, chapter 7 is devoted to axial. We'll actually look at the individual bones and think about, their features and their functions, and we'll do a lot of what we cover in chapter 7 and 8 in the lab. So I'm not going to continue anymore. This pretty much completes our chapter 6.